Greetings, fellow space enthusiasts. Are you tired of waiting thousands of years to reach other galaxies? Well, what if I told you there might be a way to travel faster than the speed of light? Before we dive in, let's remind ourselves why the speed of light is such a big deal. It's the ultimate speed limit of the universe, and no object with mass can go faster than it. But what if we could bend the rules a little bit? Enter the concept of wormholes. A wormhole is a hypothetical tunnel through space-time that could connect two distant points in the universe. Think of it as a shortcut that skips the long and tedious journey through space, like taking a secret passage in a video game. The catch? We have no clue how to create a wormhole, let alone navigate through it safely. But hey, who said space travel was easy? But let's not lose hope just yet. According to some physicists, there might be a way to travel faster than light without breaking any laws of physics. It all starts with a little thing called warp drive. In simple terms, a warp drive is a theoretical engine that could warp space-time itself, allowing a spaceship to move faster than the speed of light without actually exceeding it. Sounds like science fiction? Well, it kind of is, but hear me out. The idea of warp drive was popularized by the TV show Star Trek, but it's not all fantasy. In fact, some physicists have been working on the math behind it for decades. One of them is Dr. Miguel Alcubierre, who came up with a solution to Einstein's equations that allows for a spaceship to travel faster than light. The concept behind the Alcubierre drive is simple. Imagine a spaceship surrounded by a bubble of spacetime that contracts in front of it and expands behind it. As a result, the spaceship is not moving through space, but rather moving space itself, like a surfer riding a wave. Pretty trippy, right? But does it actually work? Unfortunately, not yet. The Alcubierre drive requires an enormous amount of energy, equivalent to the mass of Jupiter, to create the warp bubble. That's like trying to power a light bulb with a car battery. Not very practical. But don't despair, there might be other ways to achieve faster than light travel. One idea is to use exotic particles called tachyons, which are hypothetical particles that always travel faster than light. If we could somehow harness their energy, we could use them to propel a spaceship faster than light. The problem? Tachyons might not even exist, and even if they do, they would violate some fundamental laws of physics. So, we're back to square one. Is faster than light travel just a pipe dream? Not necessarily. We might not be able to break the cosmic speed limit, but we can still bend it. One way to do that is by using time dilation, a concept first proposed by Einstein himself. Time dilation means that time passes slower for a moving object compared to a stationary observer. This means that if we could travel close to the speed of light, time would slow down for us relative to the people back on Earth. For example, let's say we could travel at 99% the speed of light. If we embarked on a 10-year journey to a nearby star, only 1 year would pass for us, while 10 years would pass for the people on Earth. So, in a sense, we would be time travelers, albeit only forward in time. But what if we could go even faster? What if we could travel at 99.9% the speed of light? Well, in that case, time dilation would become even more extreme. For every 100 days that pass for us, 1 year would pass on Earth. In theory, we could travel to the farthest reaches of the universe and still come back to Earth within a human lifetime, thanks to time dilation. But there's a catch. As we approach the speed of light, the energy required to accelerate the spaceship increases exponentially. In fact, to reach even 50% the speed of light, we would need to expend more energy than the entire world's energy consumption for a year. So, unless we find a way to harness an almost infinite amount of energy, we're stuck with the snail's pace of conventional space travel. But let's not give up just yet. There might be other ways to bend the laws of physics. One idea is to use a phenomenon called quantum entanglement, which allows two particles to be connected in such a way that whatever happens to one particle affects the other, no matter how far apart they are. Some physicists have proposed using quantum entanglement to transmit information instantly across vast distances. If we could harness this phenomenon, we might be able to communicate with other civilizations across the universe in real time, without having to wait for thousands of years for a message to travel. But again, this is still very much in the realm of science fiction. So, what's the bottom line? Is faster than light travel possible? The short answer is, we don't know. We're still in the early days of space exploration, and we have a lot to learn about the universe. But one thing is for sure. The universe is vast and mysterious, and there's still so much to discover. So, let's keep exploring, keep pushing the boundaries of what we know, and who knows? Maybe one day we'll find a way to travel faster than light and reach the stars. But until then, let's enjoy the journey, because sometimes the journey is just as exciting as the destination. And who knows, maybe we'll discover something even more mind-boggling than faster than light travel. Maybe we'll find evidence of alien civilizations, or discover new forms of matter and energy we never even knew existed. The possibilities are endless, and that's what makes space exploration so thrilling. So, my fellow space enthusiasts, let's keep dreaming big, keep exploring, and who knows? Maybe one day we'll make the impossible possible. And on that note, it's time to wrap up this video. Thanks for joining me on this epic journey through the possibilities of faster-than-light travel and the mysteries of the universe. If you enjoyed this video, don't forget to give it a thumbs up and subscribe to our channel for more mind-bending content like this. And until next time, keep your eyes on the stars and your feet on the ground. This is Zeta, signing off.